Hello Internet, my name is Quinn and this is Blondihacks. Today we're starting a fun new project. The steady rest that came with my lathe is sub-awesome, so we're going to make a better one. Let's go. Here's my steady rest that came with my lathe, and let's take a look at the things that I would like to improve upon with it. This is a very typical kind of budget steady rest that you get with these import hobby lathes, and it works okay, but it has a lot of issues. So the first issue is that obviously the fit and finish on everything is, well, terrible. It consists of this casting here and then these brass fingers here, and these fingers are cast as well. They're not machined. And then there's a lead screw that runs through the middle, and then there's a kind of a cross nut here that is both the clamp to hold it in place and also the nut for the lead screw. First big problem is the feel. Because these brass fingers are cast, they're not machined, and these slots are fairly poorly machined, and then they've been painted after the fact, so there's primer and paint all gunking up the slots, so they don't have a good feel. And that's important with a steady rest because you need to know when the finger is just touching the work but not pushing on it. You'd have to support the work but without deflecting it. And so these things are stiff and they don't move very well, and so it's hard to tell, when you're contacting the work. And then the other big problem is that they've really tried to optimize the parts count on this mechanism, and what that means is that the screw action is one directional. So when you unscrew them, it just unthreads the lead screw. So you have to loosen the lead screw off and then push the finger out, and you can see how stiff it is in there. So you got to push the finger out and then loosen it some more and then push the finger out in order to retract them. That's really silly and annoying. The other big thing I dislike is the way this locking mechanism works. So these locks here, you lock them by tightening the bolt here, and that clamps this guy against the finger. However, this bolt is also the lead screw nut. And furthermore, the tightening bolt is also the same thing that retains the finger in the slot. So you have to loosen it a fair bit to get enough slack so you can move it, but then when you do that, the whole finger becomes sloppy in the slot, which again makes it hard to properly seat the finger on the work. So you have to try and strike a compromise of loose enough that it'll move, but snug enough that you have some kind of ability to acquire alignment on the surface. So that's kind of a terrible design. All of this boils down to this design is making this central bolt here do way too much. It's doing like 5 different jobs, and it's doing all of them badly. And there's also a structural issue here. So it looks like a big beefy piece of cast iron, and it is quite heavy, but really it's only as rigid as the thinnest part of the casting, and the castings are actually quite thin here. So there's this thin little web that remains around each of the fingers, and so those are going to be sources of rigidity loss and potentially sources of chatter if you're doing heavy cuts on larger material. And one other thing I'd like to improve that's somewhat optional is I'd like to go to rollers instead of these brass fingers. These brass fingers are fine. If they worked better, they would be reasonably suitable, but I would prefer a roller bearing style of finger here because it's easier to get good support without damaging the surface. And then a quality of life thing is the large T-bolt that holds the steady rest onto the ways. The size of this guy is such that it does not go between the ways on the lathe that this thing came with. So that's why it's currently unbolted, because in order to install this guy on the lathe, you have to completely disassemble this whole thing, feed this guy up from below at an angle, run the bolt through it, and then put the steady rest down on top of it. It's this whole process. So what I'd like to do is just modify the corners of this guy a little bit so that you can drop it down from the top, rotate the T-bolt into place, and lock it in. I talked about converting this guy to rollers from fingers, and this is how we're going to do that. These are ABEC 5 stainless steel bearings from McMaster Carr, and the really cool thing about them is that the inner race on them is wider than the outer race, so it's very easy to create a slot that can hold this guy in place, and you don't have to worry about something squishing it, or you don't have to create a bunch of little bushings or anything like that. So these are the bearings that we're going to use as the rollers. Here's a look at all the parts that make up one finger assembly, and we're going to reuse some of this. We're going to reuse the lead screw because it is hardened and it's got a reasonably nice fine pitch thread on it, and it is, you know, black oxided and everything. So it's a decently made part, and so we can reuse this guy. These original brass fingers I'm not going to use, but they are brass, and brass is expensive, so they'll go in the bin for some other project. And I am going to reuse one or both of these nuts because they are a good size for the device, but we won't be reusing this guy. This is that cross bolt that's also the lead screw nut and all the other things that I talked about. This is, once again, doing 5 jobs, all of them poorly. So we're going to design a different mechanism that doesn't require so much from one thing. Okay, here is the design that I've come up with. It's hopefully going to solve all of these problems. So the pink arch there is the original steady rest casting. And so in orange there, you can see the main cross nut that now goes through everything. That's going to be a new part. And then I've got a blue strap across the top there that's going to add rigidity to those slots. And then the yellow finger there is going to be out of steel. And that includes that roller that you saw earlier. And then in light green there, you can see a pin that runs through the middle there. And the green and orange pins are secured with circlips on one side, and then the orange pin is also secured with one of the original nuts on the front. And that's going to compress on that strap, and so it's not going to be displacing that cross nut, so it's not going to be deflecting the original lead screw. And then it does also include the lead screw that goes through the middle. That'll be the original factory part. And then there's a small collar there that is going to secure the factory part and give me lead screw action in both directions instead of that unidirectional action that I had before. And of course, everything's going to be machined and fit much better than the factory parts were. So speaking of fitting up parts, we're going to start by remachining the original casting. So I've widened the fingers to 750 thou. They are originally 710 because I'm going to need to recut these slots anyway. I'm going to start by setting up the rotary table because that's what we're going to need to cut those slots, and so I'm centering it on the spindle of the mill using a coaxial indicator, one of my favorite tools. I splurged on this guy because I've always wanted one, so thank you patrons for this guy. And the way this works is it runs that feeler into the bore that you're trying to align on, and you just adjust your X and Y axes until you minimize the amount of movement on that needle. It's very cool, a very fast way to align the spindle precisely on a bore. I'll do a video all about this guy coming up later. Okay, but now we have a big challenge. I need to center the imaginary center point of the steady rest on that rotary table. So first of all, I want to check that the factory slots are at 120 degrees, and I can't do this precisely, but I can get an idea. And if I put the fingers in there and bring them up into the center, you can see that actually the center point of the steady rest is not centered in that casting. So there's really no easy way to tell where that imaginary center point is. So my first idea for figuring this out was to install it back on the lathe, and I put something in the tailstock. It's a precision tool. It's actually an end mill holder that has a Morse taper 2 on it, which fits in my tailstock, and I tighten up the fingers against that end mill holder. The reason I did this is because my rotary table also has a Morse taper 2 in it. So once I've got this aligned, then I can slide the steady rest out of the way and then go ahead and put that Morse taper 2 in my rotary table and then slide the steady rest back over top of it. And this I thought was a pretty clever idea. Turned out not to work very well. The clamps that I'm using there are necessary because there's not enough room to use the original factory clamping hardware in there. It has to sit flat on their table. So the thought was, well, I can clamp it to the table and then remove those clamps, but doing this I could tell that it was moving. So I gave this a shot, and as soon as I gave it a test spin on the rotary table, I could tell that it was way off center. So this idea, it just wasn't very robust. So the second thing I tried was putting a dowel pin, a precision dowel pin, in the mill spindle and tried to just center it by eye using the fingers on the steady rest, and it was also very quickly apparent this was not going to be precise either. So the final thing that I tried was I installed the fingers, ran them into the center, clamped them firmly in place, and then using a countersink, I created a divot in the middle there, kind of a punch mark that was carved into the 3 fingers. and then I used this tool to center the fingers on the spindle. This is a tool you don't see used a lot. It's the pointy end of some edge finders that you can buy, and you use it with the spindle stationary, and you just use your fingers to feel when the two sliding components of it are aligned. And just with the touch of your fingers, you can feel, within probably a few tenths of when it's aligned. And so I was able to use this to line it up, and then very carefully put the clamps back on, and it did shift a little bit with the clamps, so then I was able to kind of tap it in place once things were snugged down. And again, just using that punch finding tool that most people don't use on the other end of their edge finder. And this turned out to work pretty well. It got me, I would say, within 1 or 2 thousandths of being correctly on center, which is going to be precise enough for this. Because the fingers slide and I've got rollers in there, it doesn't have to be absolutely perfect. So the next order of business was to line up one of the slots. Now I need to cut these exactly 120 degrees apart, so I need to line up one of the slots that's existing with what would be 0 on my rotary table. Now the trick is that the surface that I'm indicating on is both to the right of the point of rotation and behind it. So it's a bit like indicating in a vise. And so I had to kind of walk it in to get that surface aligned, because what I actually want is the center line of that slot aligned on what would be 0 on my rotary table. Now, the steady rest is not actually aligned with 0 because that would be impossible. There's no way I could get the steady rest perfectly aligned with the 0 on the rotary table and centered on it with that imaginary center point. It's too much. So what I did was just got it straight in the mill, and then whatever the reading on the rotary table was, I treated that as my virtual 0. And then I just went plus or minus 120 degrees from whatever that reading was. And then I rotated it 120 degrees to see that the next slot comes up on the same 0 on the indicator, which it should if I did everything right. Now to do this cutting, I'm going to use one of these beautiful brand new Niagara cutters that were sent to me from Dennis Nolan. He's Cutting Tool Designer on YouTube. He's a great friend of the YouTube machinist community. If you're a YouTube machinist, you've probably gotten a care package of amazing Niagara cutters from him. Thank you, Dennis. Check out his channel. I'm super psyched that I finally got an excuse to use one of these cutters, and shout out his channel. So I'm using the end mill to kind of verify that I got the slots lined up. So I check it on one slot, I rotate it 120 degrees and make sure that the end mill is coming down in the same place on the next slot. And I do seem to have achieved that. I will say this was a very difficult setup. It probably took me a couple of hours of fiddling to get what you see here that appeared to have happened in a few minutes. This was very difficult. Once I had the center lines established on my slots, it should have been a simple matter to mill half of 750 to either side of that, which should have been a 20 thou cut on each side, since the original slots were 710 and I'm widening them to 750. And what I found actually was that it was barely a cut on some sides and quite a substantial cut on other sides. So what it seems like is that the factory slots were not particularly equidistant at those 120 degree angles that they should have been. So that is probably going to throw some wrenches into my work later on, but that's all part of hopefully making this thing a better steady rest than it was. So after that first slot was milled, here you can see me unlocking the rotary table and going 120 degrees, and this required some math because of course the arbitrary starting position was, like 37 degrees in 4.5 minutes or something, so then I had to go 120 degrees off from that. Now you may have noticed that my clamps are blocking some of the slots, and so my plan was I had 2 clamps on there so I could move one while the other one held the part in place, and I could leapfrog the clamps over each other as I went around, and as we'll see later, this kind of worked. But milling the second slot seemed to go okay. I will say I was pleasantly surprised by the quality of this casting. I was expecting it, being a budget hobbyist component, I was expecting it to be riddled with cold spots and inclusions and, otherwise hastily cast. But it machined beautifully, and I found no imperfections in it at all. I'm only milling 40 thou here, but still, it went very well. Now here's where things went a little pear-shaped. As I was moving one of the clamps, as you saw there, the part moved. And I will say that was almost physically painful when I saw that, because it had taken me so long to set this up. But, there was no choice. Bite the bullet and set it up again for the final slot. After another hour or so, I did manage to get it back to where it was and proceeded. Now, what I really should have done here was made a better clamping system before I started this job. You can see I'm using some scraps of bar stock there, just clamped down into the T-nuts, and I should have made like some proper miniature strap clamps like you would use in a normal milling setup. And I didn't want to spend the time to do that, and I kind of paid the price on setup here. So A future project is going to be to make some nice small strap clamp hardware for that rotary table. Hitting my dimension on these slots was a little tricky because I don't have gauge blocks, which would be the right tool for measuring these things. So I used the end of a 3/4 inch shank end mill, which is precision ground, and that worked okay. But yeah, if you know anyone who wants to donate a set of gauge blocks to the channel, because they're kind of expensive, go ahead and drop me an email. But I will say all the pain seems to have been worth it. The slots milled up very, very nicely. You can see on the side of one slot there where the paint didn't quite clean up because that slot was so off center. But yeah, I deburred it, and after all of this stress, I decided to go on and make some easier parts for a little bit. So I'm going to make the pins that hold the roller bearings. These are going to be made from a nice chunk of 12L14 steel that I have on the junk pile, so I just bandsawed off a chunk of that. And we will set it up in the 3-jaw. This will be a quick one setup job, so the 3-jaw will serve us well here. And we're going to start by facing off the end, as is tradition. And you can see that my tool wasn't quite on center, so I fixed it and faced it off again. One of the many good reasons to start every lathe part with a facing operation is that it's actually a very quick and precise way to set your tool center height. These are not very long parts, but they are very thin, so I thought I might need tail support. So I went ahead and punched a very small center in there with a number 1 center drill, and then set up for the turning operation. And this stock is quite a bit oversized from what I need from these little pins, but it's what I have on hand. And a little extra turning trumps driving to the steel yard for me every time. And this is my go-to turning tool for roughing in steel, which you've seen many times. This guy makes great chip action and leaves an acceptable surface finish for roughing, but I did run out of room on the tailstock getting in the way there. So one of the nice things about Aloris tool posts is that they are repeatable in every aspect, so I can just remove the tool bit, clean out the slot, put it back in a little further forward. I don't have to recenter anything. Everything's going to be back where it should be, and we're back in business. Now, when to get close to the final diameter here, we're too small for my big, robust roughing tool, so I put in this slimline 55-degree tool to finish up the job. This diameter is actually the end cap of the pin, and we're aiming for 300 thou, and we came in 6/10 under that, so gotta watch myself on that for the next diameter, which is the pin where the bearing rides, and that's a lot more critical. So for that, I'm going to use an indicator on the carriage there to mark out the length of the narrower diameter, and then we're going to turn that guy down using my slimline tool. This guy we need to be dead nuts on 250 for a good bearing fit, and we came in at 250 and 1/10, so I'm not going to push my luck. We'll polish that in, but first I'm going to put a little chamfer on the end, very light chamfer, because we're going to need to put a clip on there. And you can see that our bearing doesn't quite fit because of that extra 1/10, so we'll put the surgical dressing in there. I got some 320 grit emery paper, and we're just going to massage that guy in a little bit. And now, wiggle, wiggle, wiggle. There it is. That is a perfect bearing fit. So I'm very happy with that. It spins beautifully. A fit like that is why I love machining and why I keep coming back to it. The next feature we need to make is very interesting. It's the slot for the circlip on the end. It needs to be 30 thou wide and 10 thou deep. So that's a tiny feature. So I'm grinding a special tool out of some 1/4 inch high-speed steel to do that. And I did most of it freehand on the bench grinder. That worked really well, but I needed a way to square up the inside radius that the grinding wheel left. And, well, I do have this D-bit grinder sitting over here that's not quite fully operational yet, but it does spin, so yeah, look at that. Perfect. And to get the right distance from the end of the pin, I'm using the Joe Pye razor blade technique. Thanks again, Joe, you're awesome. And then I set up an indicator, move in 20 thou, and then start making this cut. And to deburr that tiny feature, I'm using a Kratex block. They're also called Bright Boys. I learned about these from Robin Renzetti, so thanks, Rob. And you can buy these on Amazon. They're actually sold as track cleaning blocks for model railroaders, and it's just kind of a rubberized adhesive, and they are great for this type of thing. Okay, moment of truth. How does my clip fit? This is a 1/4 inch circlip, a very, very small one. It's so small that I can't even use the pliers on it. And so I'm just working this guy on with a pick and my fingers, and oh, it clicked into place real nice. It's a little bit tight. It's a little bit overstretched, so I should maybe make that slot deeper, but I think that is going to work. And now we can part this guy off. And I'm parting very gently because I got a lot of stick out here. And Yahtzee. Now I'll need to flip that guy around and face off the end, but I need 3 of these pins, so I'm just going to make 3 more with this same setup. Now before I go and face off all those pins, since I had the stock already set up in the lathe, I decided to also make those retaining washers that hold the lead screws in place. And so I just turn this guy down to my outer diameter. And once again I missed that diameter of 300, but this time I missed it by 1/10. That's 299 9/10. I'll take that. Not at all a critical dimension, but feels good to hit it anyway. So a little deeper, and now we'll do a little test fit with that lead screw, and it doesn't fit at all. What? Imperial fist shake. Oh, right. Yeah, I actually need to make a hole. So the challenge here is that the thread on this lead screw is actually a larger diameter than the shoulder at the top of it, which is annoying. So I have to size them for the thread. So it's going to be 197 thou. It's going to be a little bit oversized on the collar, but we'll worry about that later. And now another test fit, and it fits much better than when there was no hole. Now I made 1 long bushing, but what I really need is 3 little bushings. So using, once again, the razor blade trick, and then I move over 100 thou, and we'll part this guy off. And I part in part of the way, pardon the pun, and go back in with a needle file and deburr that back side. These are very small parts, so I gotta be careful. I'm in close to the chuck here. And then finish the job. And Yahtzee, Yahtzee, Yahtzee. And these are a little tricky to deburr because they're so tiny, but some flat-nosed needle nose pliers will take that rogue chip off of there. And then I can deburr that inside edge with a small handheld countersink. And here's our 3 bushings. I'm very pleased with how those turned out. The razor blade there is for scale. You can see how small these guys are. I think they're going to work great. Okay, now let's set up to face off the ends of those pins. I left them all thick so that we could face them down to final size. So I'm measuring how thick this pin currently is, so I know how much to remove. And then I'll set this guy up in the 3-jaw, and I'm using a piece of aluminum can to wrap that guy in so that the jaws don't damage it. And you'll note that the seam in the can is aligned with the gap between 2 jaws so that there's no overlap and the gap doesn't cause run out. And then I gently face this guy down to the final dimension that we need. And then a very careful, very tiny chamfer, because hey, if we're spending all this time rebuilding a crappy steady rest, we might as well go crazy and make it beautiful. The great thing about this aluminum can trick is I can just loosen the chuck, slide the part out, can stays stuck to the jaws, slide the next part in, snug it up, Bob's your uncle. And aluminum cans are actually made extremely precisely. They are very consistent in their thickness because it saves the aluminum can company money. So they can be used as light-duty shim stock, or in this case, they don't add any run-out to the setup. All right, in addition to remilling the casting, we now have all of these parts made for our project so far. So I've got these little pins, and you can see how the rollers slide on there very nicely. And then those circlips there are going to go in those grooves and hold it all into the end of each finger. So I'm very pleased with how this is going so far, but that is all the time we have today. Thank you very much for watching. Please do consider supporting me on Patreon. Patronage is what makes this channel possible, and we'll see you next time.